Salam dear students, my name is Ahsan Hassan. I'm going to explain for you a new physics lesson which is the voltage of the mains. In this chapter, we will talk about the electricity provided in Lebanon by the EDL or the National Company of Electricity, the characteristics of this electricity, its dangers, and how we can protect ourselves and our houses from these dangers. First of all, let's check the objectives together. In this video, we will cover 3 objectives. Characterize the voltage of the mains in Lebanon. Describe the terminals of the wall outlet and the voltage across each of them. Explain how power line supplies voltage to domestic apparatus. The last 2 objectives will be covered in other videos. First of all, let's see how electricity is provided to houses and buildings. First of all, we have power stations. These power stations use different sources of energy to produce the electricity. This electricity will be transmitted through national transmission lines to substations. Again, from these substations, the electricity will be transmitted to houses, shops, factories, and other buildings through lines or cables as well. But how does this electricity feed electric appliances or devices inside houses? As you might know, through the wall outlets. So to turn on an electric device, we should plug it in a wall outlet. In Lebanon, in our houses, we might find 2 types of wall outlets. The first one has 2 female terminals. One terminal is called the neutral terminal and the second one is the live. So these are the live and the neutral terminals. Now we can know which one is the live and which one is the neutral. The second type of wall outlets has 3 terminals, similar to the first one, 2 female ones called the neutral and live, and in addition, 1 male terminal called ground. To identify these terminals, we will perform the following activity, which is activity 1, page 84. In this activity, we'll use a device called live mains indicator or tester. Let's check the parts of this device. The tester or the live mains indicator has 3 main parts: the metallic head, the neon lamp, and the metal cap. What are the steps that we should follow to identify the terminals using this device? We should put our thumb on the metal cap and insert the metallic head of the tester in one of the female terminals. Here, the circuit is closed. If the voltage is higher than 80 volts, then the neon lamp will glow. Let's watch the video together to identify the terminals of the outlet. Here, as you can see, the finger is put on the metal cap and the metallic head is inserted in the female terminal. The neon lamp is glowing. This means what? That the voltage is higher than 80 volts. Then this terminal is the live terminal. The second tester, the finger is put on the metal cap, but the neon lamp does not glow. This means that the voltage is less than 80 volts. Thus, this is the neutral terminal. Here we can say that the electricity of the mains is delivered through the live terminal, where the voltage is higher than 80 volts. Let's measure this voltage. To measure the voltage of the mains, we will perform activity 2, page 85. In this activity, we will use a multimeter functioning as a voltmeter to measure the voltage. We will measure the voltage across the live and the neutral terminals, the live and the ground terminals, the ground and the neutral terminals. Let's check the results which will be obtained. In the first case, where we measure the voltage across the live and the neutral terminals, the voltage is 216, which is approximately equal to 220 volts. In the second case, where we measure the voltage across the live and ground terminals, the voltage is also 220 volts. And in the last case, where we measure the voltage across the ground and the neutral terminals, the voltage is approximately 0. So to summarize these results, the effective voltage across the live and the neutral is 220 volts. Across the live and the ground, also 220 volts. And across the neutral and the ground, it is equal to 0. So to sum up, let's summarize the characteristics of the electricity of the mains. From this oscillogram, we can deduce the type of this voltage, which is alternating sinusoidal voltage. The effective voltage, U effective, is 220 volts. And the maximum voltage can be calculated from the effective voltage, and the frequency F is equal to 50 Hz. The last point which we will discuss in this video is the domestic electric installation. This will be done in Activity 3, page 86. Let's observe this figure, which shows many electric appliances connected to the electricity of the mains inside a house. So as you can see, all of these appliances are connected to the wall outlets, and these outlets are fed by the electricity of the mains. These appliances are connected, all of them, to a circuit breaker, which is a switching off device found in all houses. This is a schematic diagram that shows these connections. These electric appliances are connected in parallel. And this is the electric meter, which feeds the house by electricity. And between these two, we have a circuit breaker. These electric appliances are connected to 3 lines: the live line, the neutral line, and the ground line, which is also called earth line. So what are the characteristics of this domestic electric installation? So a domestic electric installation is formed of electric appliances connected to an electric meter, and a circuit breaker is installed between these two. And since these appliances are connected in parallel in a domestic electric installation, then the characteristics of this installation will be that appliances work independently. This means that if one appliance stops working accidentally, the other appliances will continue working normally, And according to the law of uniqueness of voltage, the voltage across the appliances will be the same, which is 220 volts.